Okay, so we're going to review a little bit about regression, but we're also going to look at a different way, a different way of analyzing the data. So, first of all, we want to check to see if the x values are evenly spaced. They don't have to be going up by 1, but they have to be evenly spaced. So, this is plus 2. This is plus 2. Nope, not minus 2. Minus 2, minus 2, minus 2. So they're evenly spaced, but they're going down by 2. All right, so now on the right side, we're going to check what we call first differences. 13 minus 16. I'm going to do plus 3, yeah. Plus 3, plus 3, plus 3, plus 3, plus 3. So these are the differences between the y. These are called first differences, which is why it makes sense if you subtract, but it's the difference. If a table represents a linear function, then the first difference is constant. I don't know why the word "the" is there. The first difference is constant. All right, so now we look at the next one. These are going up by 1. So they are constant difference apart. But I look at my differences here. 16 minus 9 is what? And 9 minus 4 is? And 4 minus 1 is? And 1 minus 0 is? And 0 minus 1 is? And 1 minus 4 is negative 3. Those differences are not constant. So this row represents the first differences. Those are not constant. So now we check the second differences. What is 7 minus 5? What is 5 minus 3? What is 3 minus 1? 1 minus negative 1. And negative 1 minus negative 3? 2. If the second differences are constant, then it's quadratic. So if a table represents a quadratic function, then the second differences is constant. I don't know why the word "the" is there. Now, as it turns out, this continues to be true. If your second differences are not constant, but your third differences are constant, it's cubic. If your fourth differences are constant, guys, if your fourth differences are constant, it's quartic, and so on. That continues to apply. If the differences are not constant, but rather a multiplier, then it is exponential. So I check these. They're going up by 1. So they are evenly spaced. What do I have to multiply 1/9 by to get 1/3?
3.
So we're going to multiply by 3. What do I multiply 1/3 by to get 1?
3.
What do I multiply 1 by to get 3?
3.
And what do I multiply 3 by to get 9?
3.
Right? So each one of these, this is called a ratio. If a table represents an exponential function, then there is a common ratio for each y value. The ratio is a multiplier. Is a multiplier. All right, you're going to use this information, a calculator if you need to, but I don't think you will need to for what we're going to do. Today's Desmos is a matching. The problem has become that people have stopped working the Desmos. They just look up at the screen and drag one over and say, did it turn green or red? And then they drag it away. They drag another one over and say, did it turn green or red? And they drag it away. That's not helping you. That's not practice. So I'm not going to put the screen up that shows you if you're getting them right or wrong until after you've worked on it for a while. So sometime after lunch, when you've had a chance to work on it, then I will put the screen up before the end of class so that you can see if you're getting them right. Yes, the remainder of this page, the equation and the graph is for you. So you'll need to put this data into the calculator, get the calculator to give you the regression equation, write the equation in the boxes, and draw the graph. So you're going to finish this page just using the calculator to finish that on your own.